Hello, this is Miss Igo. Welcome to my classroom. Today we're going to talk about absolute value equations and inequalities. Absolute value is the distance of a number from zero on the number line. When we write the absolute value equation, the absolute value of x equals 7, what is the solution set? Well, what we're asking here whenever we have this equation is, what value of x would have a distance from 0 of 7? Well, let's look at our possibilities. If we start at 0, we could go to the right 1, 2, 3, 4, 5, 6, 7 spaces, and therefore x would have a value of 7, or 7 is the distance of 7 spaces from 0 on the number line. But we could also go in the opposite direction and go 1, 2, 3, 4, 5, 6, 7 spaces to the left, and that means negative 7 also has a distance of 7 from 0 on the number line. Therefore, the solution set to the absolute value of x equals 7 would be 7 and negative 7, because they both have a distance of 7 from 0 on the number line. So, to solve an absolute value equation, you must write two equations and solve both, because we have to take into account both directions from 0 on the number line. Our first example asks us to solve the absolute value of 4x equals 20. So in order to do this, our first step in solving any absolute value equation is to get the absolute value by itself on one side of the equal sign. So that's already done for us. The absolute value of 4x is on one side of the equal sign. Then we take that out of the absolute value. So now we're saying that this distance, 4x, is 20 spaces from 0 on the number line. Well, we also have to take into account the other direction. If we go the other direction on the number line, that value inside the absolute value also goes in the opposite direction. So we have to set it equal to the same number, but in the opposite direction. And then we solve both of these equations. So to solve this equation, 4x equals 20, we divide by 4, and we get x equals 5. And for our other equation, when we divide by 4, we get that x equals negative 5. Now, let's check our solutions to make sure they work. All I have to do is plug in my solution set into the original absolute value equation. So that would be the absolute value of 4 times 5 equals 20. Okay, so 4 times 5 is 20. And the absolute value of 20, the distance that 20 is from 0 on the number line, is 20. Okay, so let's try negative 5. The absolute value of 4 times negative 5 equals 20. Again, we plug it into the original equation, not once we've taken it out of the absolute value. So 4 times negative 5 would be negative 20. But what is the value of negative 20? Or how far is negative 20 from 0 on the number line? It's 20 spaces. So both of these check out, and that makes both of these part of our solution set, 5 and negative 5. Okay, here is another absolute value equation. This is the absolute value of 1/2 x plus 3 is equal to 2. Again, our first step in solving an absolute value equation is to get the absolute value by itself on one side of the equal sign, which is already done. And then we take it out of the absolute value. So we take it out of the absolute value and write it one time just like it is without the absolute value symbols. So I have 1/2 x plus 3 is equal to 2. And then we write it again, 1/2 x plus 3 is equal to the opposite. So it would be minus 2, or is equal to negative 2. Okay, so let's solve these two equations. I'm going to subtract 3 from both sides. And that gives me 1/2 x equals negative 1. So to get rid of a fraction that is a coefficient of a variable, I want to multiply by the reciprocal. 1/2 is being multiplied by x, so we would divide by 1/2, but we can't divide a fraction by a fraction. When we try to divide a fraction by a fraction, we need to multiply by its reciprocal instead. So I'm going to multiply by the reciprocal of 1/2, which is 2 over 1. All right, which causes this to be 1 over 1. And we say it cancels out, but that turns into a 1 or 1x equals negative 1 times 2 over 1 would give me a negative 2. For my other equation, I'm going to subtract 3, but when I subtract 3 from a negative 2, that gives me a negative 5. So I have 1/2 x is equal to negative 5. So I'm going to do the same thing. I'm going to multiply both sides by the reciprocal of 1/2. This would turn into a 1x is equal to negative 5 times 2. That would be negative 10 over 1, which is just negative 10. Okay, so let's check and make sure that these work in our equations, in our absolute value equations. So I'm going to plug it into the original absolute value, 1/2 times negative 2. So I'm going to write that as negative 2 over 1, x plus 3 is equal to 2. Okay, so if I multiply this together, I get 1 times negative 2. That's negative 2 over 2 times 1, which is 2, x plus 3 equals 2. Okay, negative 2 over 2, that would be a negative 1. Okay, I was supposed to be plugging in negative 2 over 1 for x, so there should not be an x here. Okay. All right, so this would just be negative 2 over 1, which is negative 1 plus 3 equals 2. Okay, and negative 1 plus 3 would be 2. So what is the absolute value of 2? Or how far is 2 from 0 on the number line? It would be a distance of 2. Okay, so negative 2 checks out. Let's try negative 10. Okay, so I'm going to plug in negative 10 for x. Again, that would be like 10 over 1. Negative 10 over 1 plus 3 equals 2. Okay. Half of negative 10, whenever we multiply by 1/2, we're basically taking half of the number. I multiply 1 times negative 10, I get negative 10. 2 times 1 is 2, so that's the same thing as negative 10 over 2, or negative 10 divided by 2, or half of 10. So that would be negative 5 plus 3 equals 2. Well, negative 5 plus 3 would be negative 2. And the absolute value of negative 2, or the distance that negative 2 is from 0 on the number line, is 2. So again, that is correct. That is our solution set would be negative 2 and negative 10. All right, in this equation, the absolute value is not by itself on one side. So that's our first step, is to get the absolute value by itself on one side of the equation. So the very first thing I need to do before I take anything out of the absolute value is to move that -2 over to the other side by adding 2. And that gives me the absolute value of x plus 5 equals 14. Now, once the absolute value is by itself on one side of the equal sign, then I can take it out of the absolute value. So that would give me x plus 5 equals 14. And then I also need to set it equal to the opposite. X plus 5 equals -14. To solve this, I'm going to subtract 5 from both sides, and that gives me x equals 9. And x equals a -23. Just kidding, trying to see if you're paying attention. It would not be -23 because I would not be subtracting 9 from both sides. I would be subtracting 5 from both sides, which would give me a -19. Are you awake? Okay, let's move on to the next equation. Just like the equation before this, the absolute value is not by itself. So the first thing we want to do is get the absolute value by itself on one side of the equal sign. So to do that, I'm going to subtract 3. All right, that gives me x plus 7 equals -2. Well, there's a problem because absolute value, again, the definition of an absolute value is the distance that a number is from 0 on a number line. So this statement, the absolute value of whatever this is in here, equals -2. We can't have a negative distance. Distance is only positive. So the absolute value of something can never equal a negative number. Now, just in case you forget that and you work this out, let's see what happens. Let's work out this equation. So again, I would take this out of the absolute value and say x plus 7 equals -2. And then again, x plus 7 equals the opposite of -2, which would be +2. Okay, so let's solve this. I'm going to subtract 7 from both sides. And I get x equals -9. Subtract 7 from both sides. And I get x equals -5. Okay, let's check those answers. To check -9, again, go back to the very original absolute value equation and plug in your solution where x is. So I have the absolute value of -9 plus 7 plus 3 equals 1. Okay, so the absolute value of -9 plus 7, that would be the absolute value of -2 plus 3 equals 1. Well, what is the absolute value of -2? It would be 2. How far is -2 from 0 on a number line? It's 2 spaces. So that gives me 2 plus 3, which is 5. And 5 does not equal 1. Okay, so that's what I got when I plugged in 9. So 9 did not work. Let's try -5. Or -9 didn't work. Let's try -5. Okay, so we have the absolute value of -5 plus 7 plus 3 equals 1. So -5 plus 7 would be a +2. And the absolute value of 2 is 2. And 2 plus 3 is 5. And again, 5 does not equal 1. So -5 also does not work. So if you notice, once you get the absolute value by itself on one side of the equation, if it equals a negative number, that's not going to work. But if you also are in the habit of checking your solutions every time, you'll see that that doesn't work. So this problem would just have no solution. To solve an absolute value inequality, you will need to write two inequalities, which would make it a compound inequality. When writing the two inequalities, it's very important to choose the correct connecting word. Your connecting word will either be and or. So follow these rules to decide. If the original inequality has less than or equal to, use the word and. If the original inequality has greater than or equal to, use the word or. Now, it's very important when you are choosing the connecting word and looking at your inequalities that the absolute value is on the left side of the inequality. So your absolute value has to be first, and then if it's less than or equal to, use and. If the absolute value is first and by itself, then if the inequality is greater than or equal to, then use the word or. All right, here is an absolute value inequality, and we are to write the solution set in both graph and interval form. So in this inequality, we have the absolute value of x is greater than 4. So we have to take this out of the absolute value symbol, and we're going to write it twice. So this would be x is greater than 4. And we would also write x is less than the opposite, which is negative 4. So when we're dealing with inequalities, we not only do the opposite of the number, both the positive and the negative, but we also flip the inequality symbol. Okay, and now to determine what our connecting word is, the absolute value has to be first on the left side by itself, and then if it's less than, it's and, greater than, or. And we're looking at the original one. So since it's greater than, then our connecting word is going to be or. So remember that if it's and, it's going to be only the part of the graph that overlaps. If it's or, then it's going to be anything that's in either graph. So if I were to look at the graphs of these separately, x is greater than 4. We would use a parenthesis on the number 4 and go to the right. And x is less than negative 4. We would use a parenthesis on negative 4 and go to the left. These are not connected. So if it were and, we would not have anything that's connecting each other. But since it's or, it doesn't matter. It's just going to be anything that's in either graph. So we're just going to put both graphs on the equation. X is greater than 4 and x is less than negative 4. Now remember, we have symbols for the words and for the words or. And is the intersection, and we use the upside down U. Or is the union, so we use the U for our symbol. So when we write the interval, we're going to have to use a symbol. And because our connecting word is or, we're going to use the U symbol. And always remember that our intervals go from left to right. So since there's an arrow pointing to the left, that means it goes on forever. So on the left, we're starting at negative infinity. And then, if you'll also remember, we always enclose infinities with parentheses, never a bracket. And it goes from negative infinity to negative 4. We close it with whatever symbol is on the number. And then it picks back up at 4 and it goes to positive infinity. And we close that with a parenthesis. And then to connect these two intervals, we say this is the union of these two intervals. And we put the union sign symbol in between those two intervals. Here we have the absolute value of x is less than or equal to 4. Again, the absolute value is by itself on the left side of the equation, or the inequality. So we take it out of the absolute value symbols, and we have x is less than or equal to 4. And we write it again as x is, we flip the inequality, is greater than or equal to -4. Now to determine our connecting word, we look at the original inequality, and that's less than or equal to. So less than is and. Okay, so let's look at the two separate inequalities. We have x is less than or equal to 4. So on the number 4, because it's the less than or equal to symbol, we're going to use a bracket instead of a parenthesis. The less than or equal to, remember, this line underneath reminds me of the lines in the brackets. So that's what I am going to use when I draw these inequalities. Let me not put this on the line yet. Okay, so we know that it's on bracket on 4, it's less than, or it looks like an arrow pointing to the left, so that's going to go in that direction. And then x is greater than or equal to -4. So on -4, again, we would have a bracket, but this time we go to the right because my inequality symbol looks like an arrow pointing to the right. And if you'll remember, we only can use that trick if our variable is first. So our connecting word is and, which means we can only put on the graph the part that is overlapping. So this arrow keeps going to the left forever. Let me see if I can, let's do this. Okay, so it keeps going to the left forever, and this one keeps going to the right forever to infinity. So it only overlaps between -4 and 4. So that's the part that's going to go on my graph. And we use whatever symbol of the line that ends on that number. So -4, this line ends on -4, and it has a bracket on -4. So that's what's going to go on my -4. The top line ends on +4, and it has a bracket. So I'm going to put a bracket on +4 and then just connect the two. So that's the overlapping part of the two lines. And we only did the overlapping part because our connecting word was and. So our interval is going to go from left to right. We start with a bracket. It starts at -4 and it goes to +4. And we close it with a bracket. All right, here's an inequality that has a little more work to do. We have the absolute value of 4x plus 1 is greater than or equal to 21. So the absolute value is by itself on one side of the equation. So we can go ahead and take it out of the absolute value symbol, and we have 4x plus 1 is greater than or equal to 21. And then we're also going to have 4x plus 1 is less than or equal to -21. Let's work those out. Excuse me. I'm going to subtract 1 from both sides, and that gives me 4x is greater than or equal to, that would be 20. I divide both sides by 4, and I get x is greater than or equal to 5. For the other inequality, I'm going to subtract 1 from both sides, and I get 4x is less than or equal to a -22. Divide by 4, and x is less than or equal to, that would be a -11/2, or we could say a -5.5. Okay, so we back up and we look at our original inequality to determine our connecting word. Remember, less than is and, greater than is or. So since this is greater than or equal to, our connecting word is going to be or. So let's look at what our graph looks like. X is greater than or equal to 5. It's got that equal to part, so we're going to have a bracket on 5, and it's greater than that, so we're going to go to the right. X is less than or equal to -5.5, so -5.5 would be between 5 and 6, and it's less than that, so we're going to go to the left. Okay, because our connecting word is or, that's going to include anything that's in either graph. So let's just put these on the line like this, and that's what our graph looks like. Just the red part. And our interval, again, goes from left to right. We're starting where? Negative infinity, and we use a parenthesis. It goes from negative infinity to negative 5.5. We close that with a bracket. And remember, for or, that's the union, so we're going to put a U. We pick back up at 5, and we go to positive infinity, and we'll close that with a parenthesis. Okay, this absolute value inequality has the absolute value of negative 5x plus 3 is less than 12. The absolute value is by itself on the left side of the equation. Let's take it out of the absolute value symbol. So we have negative 5x plus 3 is less than 12. And we also have negative 5x plus 3 is greater than negative 12. Okay, so when we go to solve this, we want to isolate the variable, so we're going to subtract 3 from both sides, and we get negative 5x is less than 9. Then we divide both sides by negative 5, but anytime we're dealing with an inequality, if we multiply or divide both sides of the inequality by a negative number, we have to flip the inequality symbol. So flip that inequality symbol, and negative 9 over 5 would be the same thing as a negative 1 4/5. It's a lot easier to graph a number on the number line whenever it's a mixed number instead of an improper fraction. Okay, so then for the other inequality, subtract 3, but when I subtract 3 from a negative 12, then that's going to give me a negative 15 because I add them together. Let's see. Negative 15. Okay, then I need to divide by negative 5. So once again, I'm dividing by a negative number, which means I need to flip my inequality symbol. And that gives me x is less than 3. Okay, but I'll look at my original inequality, and I see that's less than, so that means my connecting word is and. Okay, so I'm only going to be graphing the parts of the graph that overlap. So this first one says x is greater than negative 1 4/5. Okay, so negative 1 4/5, that would be close to negative 2. And since it's just greater than, not greater than or equal to, we would use a parenthesis, and it goes to the right. And then x is less than 3. We would start at 3, and we would go to the left. Okay, so the part that's going to be on my graph is the part that overlaps. Well, it starts overlapping at negative 1 4/5, and I would use the symbol of the line that ends there. So I'm going to use the parenthesis, and negative is probably a little closer to 2 than that. So that's negative 1 4/5, and then on the other end, it's going to end, it stops overlapping at 3. So I'm going to put my line on 3, and then it's just the stuff in between. So my interval would start with a parenthesis, always go from left to right, parenthesis, negative 1 4/5, and it goes to 3, and we close that with a parenthesis. All right, here's a little warning. Make sure that you pay attention to the meaning of the connecting word. So in this inequality, we have that the absolute value of x plus 5 is greater than negative 9. Okay, so if we think about that statement, remember we said that an absolute value cannot equal a negative number. All right, so this is an inequality, and this is saying that whatever is in this absolute value is greater than negative 9. Well, that means that it could be anything greater than negative 9. So it could be negative 8, negative 7, and so forth. Or it could be a positive number. So that's possible, and we should work this out, but check our solutions. Okay, so we are going to take this out of the absolute value symbols, and we have x plus 5 is greater than negative 9. And we also have x plus 5 is less than, and we change the, do the opposite number, so that would be a positive 9. Okay, so I'm going to subtract 5 from both sides, and I get that x is greater than a negative 14. And for the other side, subtract 5, and that gives me x is less than 4. Okay, so let's check these solutions. Now, this says we check inequalities a little differently than we do equations. We don't plug in the exact number unless it's equal to. So this says x is some number greater than negative 14. So we have to pick a number that's greater than negative 14. I'm just going to choose the next number, which is negative 13. That's greater than negative 14. So I'm going to plug in negative 13 into our original absolute value inequality. All right, negative 13 plus 5 is greater than negative 9. Okay, negative 13 plus 5, that would give me a negative 8. Okay, but what is the absolute value of negative 8? It would be 8. So this says 8 is greater than negative 9, which is true. So that means this is a good solution. Okay, for the other one, x is less than 4. So we need to pick a number that's less than 4. I'm just going to go with the next number, which is 3. If I plug in 3 into my original absolute value inequality, I get 3 plus 5. The absolute value of 3 plus 5 is greater than negative 9. Well, 3 plus 5 is 8, and the absolute value of 8 is 8, and it is greater than negative 9. So this is also true. All right, so let's graph this. X is greater than, first of all, we got to see what our connecting word is. Less than is and, greater than is or. So this is going to be or. So if you'll remember, when it's or, that means anything that's in either graph. Okay, so x is greater than negative 14. I'm going to have to add to my graph here. So this is not to scale, so I'm going to, that would be 11, 12, 13, 14. Okay, so we're going from negative 14 and all the numbers greater than that. So everything to the right of that. That's pretty crooked. That's crooked too. My goodness. Okay, it's got to go a long way to get to the 4. Okay, and then for x is less than 4, we start at 4 and we go to the left. Well, if I put anything that's on either line, if I put them together and put them on the graph, this goes forever to the right, the bottom one goes forever to the left, and they completely overlap each other. So that means the whole number line is covered. So I can just put an arrow going to the left and an arrow going to the right. So that means our interval for our solution set is going to be from negative infinity to positive infinity. Okay, this is our last example. We have the absolute value of 4x plus 1 minus 2 is less than negative 5. Okay, so the very first thing we have to do is get the absolute value by itself. So I'm going to add 2 to both sides, and that gives me the absolute value of 4x plus 1 is less than negative 3. Okay, so let's think about what that's saying. That's saying that this absolute value, whatever this value is, the absolute value, the distance that it is from 0, is less than -3. Well, any numbers less than -3 are going to be negative, and an absolute value cannot be negative. So we should know just from that statement, this is not going to be true. But again, if you don't notice that, if you don't pick up on that, let's see what happens. Let's work it out like we would the other absolute value inequalities. Let's take it out of the absolute value. 4x plus 1 is less than -3. And then we do the opposite. 4x plus 1 is greater than +3. Okay, so I'm going to subtract 1 from both sides. And that gives me 4x is less than -4. Divide by 4. I do not flip the inequality because I'm dividing by a positive. So that's x is less than -1. And then when I do the other one, I have 4x is greater than 2. Divide by 4. And I get x is greater than 2 over 4 would reduce to 1/2. Okay, let's look at the connecting word. The connecting word is less than, which means, or the inequality symbol is less than, which means my connecting word is and. So it's only going to be the parts of the graph that overlap. Well, let's see what they are separately. I have x is less than -1, so a parenthesis on -1 and it goes to the left. X is greater than 1/2, so it would start at 1/2 and go to the right. So if I'm looking for the part that overlaps, nothing overlaps, which means there would be nothing that I would be able to graph. And that also means that my interval would be that there is no solution. So if you notice that it's something that's impossible, this is saying that we have a distance or an absolute value that's negative because it's less than -3, we know that there's going to be no solution. But if you work it out, you're going to see that there's no solution. Thank you for watching.